Audio, 1, 2, 3. Okay, Mr. Versa, do you have audio now? Do you have audio now? Give me some feedback there on your YouTube. I see you joined us. All right. Fantastic. I'm going to start our transmission again. All right. So that all right, you should have audio now. Okay, I'm going to start audio. Okay, we've got audio. Welcome to West Virginia. This is James Rumsey Technical Institute. We are live streaming from Martinsburg, West Virginia. This is the electromechanical technology class. We are distance learning. This is a hands-on electromechanical class. So this live stream is geared for hands-on training. My students have their electrical boards at home and their various microcontroller interface boards with them, and they are actually doing the actual work live stream live while we are doing distance learning. They will send me results via video snippets and digital uploads of the work that they do so that I can monitor to see how the hands-on learning is going. And so we are learning. As an instructor, I am also learning how to do the online presentation of the work. Okay, for those who are watching who are not part of the electromechanical technology class, what we do here today, please do not do this at home. Okay, my students have had extensive training in electrical safety and electromechanical safety as it relates to what we do here. So please do not do this at home if you have not attended my safety classes. Okay. For my students, June 4 is a very important date. June 4. That is the day that you will come to the school to return the blue electrical boards. It's also the last day to turn in any homework that you still want to turn in for credit in order to get that to be on your transcript, as well as that will determine whether you get your diploma. Last week, May 13 was the last day to turn in homework for a passing grade if you want to be listed in the June 10 live stream graduation. That doesn't mean that if you did not have a passing grade at June 13 that you cannot get a diploma. It just means that you will not be listed in the live stream graduation. If you continue to turn in the homework that is due until June 4, that is the deadline, that is when I do the final grade book, and that will determine whether you get your diploma. There is one other factor that determines whether we send you your diploma, and that is you must come in June 4 at 8 a.m. to the school. The gate will be open. There will be somebody who will let you in. You will come up to the classroom. You will be contacting me one at a time, and I will let you bring your electrical boards into the classroom. You will be issued masks and gloves for safety. We will take those boards, we will disinfect them and make sure that they are safe for students for next year. This is required by the county health department. From there, those who choose to take the EPA exam will come into the classroom, set up your laptop, we will connect, and you will take the exam. Okay? I will be there to proctor the exam. If you want to take the EPA 608 exam, you must email me today an email indicating that you want to take the 608 exam on June 4. Okay, I must have that email. Okay, now let's take a look. There's something else that's very important that's going to be happening. I want you to look at the calendar. The last day of live streaming is going to be May 28. However, May 28 will not be a regular 11 o'clock live stream. It's going to be a much later one. It's going to be around 2 or 3 o'clock. I'll let you know the final time. Actually, it's going to be more like 4. What's happening on the 28th is I will be assisting at the school for the high school students returning their equipment to the school, as well as picking up their personal belongings. Now, if you have any personal belongings, I know there's at least one of you that has something in the classroom. I'm going to have you send me an email of what it is that you need to pick up. Okay? That will also happen June 4. You will pick that up when you drop your board off. You will pick that equipment up. We will photograph it. We will document what you picked up. And so if there is any of you who have anything in the classroom that needs to be picked up, you will need to email me of what it is you need to pick up so that I can make the arrangements to get it ready for you so that you can pick it up when you drop off the board. Okay, I must have an email to that effect. Okay, you know who you are. Okay, now let's look at what other important information there is. If you have any other questions regarding the dates, please email me. Okay, you must email me. Do not message me for that. I will be communicating that via email. Okay, all right. Today's class exercise is going to be the combination of what we did over the last 2 weeks. Remember, we built a servo motor microcontroller board, and last week we built the Aquastat motor board with our test code. And so now the next stage is connecting the two systems together and hooking up our AC loads. We're still going to do this with test code. I don't want you to be worried about any logic at this stage. We already have our test code. We're purely going to make the interconnect to see whether the wiring is complete. All right? So we're going to look at that today and see what does that involve. We're going to look at some terms that's used in the industry and so on. Okay. I'm going to go ahead and I'm going to bring up a wiring diagram. All right. And let's take a look at that wiring diagram. Okay. Let's see. There we go. There is our familiar diagram that we made for our servo, which is our zone controls. Okay, we're going to have two zones, and they are controlled by two thermostats, which connect to these points here where the optocouplers are, and that's going to be 24 volts driving that, because a thermostat runs off of 24 volts. So that's what's going to happen there. Now, you recall that we had two relays here, one representing each zone. So when a zone calls for heat, it's going to close these contacts right here for zone 2 and for zone 1. So in the industry, once we have this part wired, we will put this in a box, and we call it a black box. All right? And the only thing that we care about at that stage is, because we've already run our test code, is what connects as inputs and what are outputs, and that's what we worry about. So, having said that, this is a black box that only has 4 sets of connections, 2 for thermostats and 2 for the outputs that will drive the aquastat, right? So we have our thermostats that'll tell us when we need to have heat for the 2 zones, and then the 2 outputs which represent the zone outputs telling the aquastat that it needs heat, all right? So there's only 4 sets of connections that we need to make there. Now we're going to look at the aquastat drawing in terms of how that looked, and that is right here. All right, and here we go. Remember, this is the one we did last week, correct? All right. You remember we have one optocoupler. Now you notice there's only one optocoupler, and it says this is call for heat, call for boiler. Remember on our servo, in fact, let me see if I can put them up both together here. Let me see. All right, here's the one. Let me go see if I can get the other picture. Let's go see. Let's see. All right. Yes. Let me see if I can get that photo up. All right. Here we go. This is a photo. Just give me a moment here to size them. Okay. Actually, let me see if I can bring that one up. There we go. All right. That's this one. And let's bring our Word document up. Okay. All right. Just give me a moment. There's our Word. Okay. And here is our aquastat. All right, almost there, guys. Let's see if I can slide this over. Let's sit that right there. And let's bring this over. All right. Okay, how's that look? All right. So, if we look at, we already said that this zone control has 2 thermostatic inputs and 2 outputs to call for heat at the aquastat. However, when we looked at our aquastat drawing here, if we look at our aquastat, we only have 1 input for boiler call, but we had 2 outputs from the servo motors, right? Servo for the zone 1 and zone 2. 2 outputs to call for heat over here. So how do we deal with this? We only have 1 input on the aquastat. That's not a problem, because remember, we are calling for heat on the boiler. Now remember, if we call for heat on the boiler, we only need to know when the boiler needs to run. Whether the boiler doesn't care whether it's zone 1 or zone 2, because remember, the zone valves are the ones who are going to determine where the water goes, and the boiler just needs to know, hey, I need to make hot water. So it just needs to know either one, is it one or the other, okay, in order to set that out there for us. And so that is why, if we go back to our drawing now, that is why the aquastat only needs 1 input. And we've learned earlier this year that when we parallel two switches as inputs, it is a OR. This one or this one, if either one of those closes, it will be a ON over here on our optocoupler. So we're just going to hook them in parallel, and we'll see that here in a little bit when we go look at the wiring. So that takes care. We know we need to make that connection. We already have these done from previous. Well, we'll hook up our 24 volts and make sure we have a way to connect 24 volts to either side of that. And then we are going to connect these two outputs from these two relays to this one input on our Aquastat microcontroller board. Okay, we're going to see how to do that today. Then the only other thing we have left to connect is the output of our solid-state relays. They are going to be controlling 4 AC loads, right? A fuel solenoid, a circulator pump, a burner motor, and an ignition coil and fuel solenoid. Okay? And so that is the pieces that we are going to need. In fact, I'm going to make, this is where you'll make your final adjustments to these tags, all right? Because based on what you have here will determine what these outputs, remember your outputs from your Arduino, they are driving here, and we will be looking at those in our code, because remember our test code is already there, we already tested this, and now we just want to make sure, can we turn on the AC lights? And depending on what we connect here will be what gets turned on. So once we have that, we have to make sure whatever connects here is what we're actually going to be controlling. So if this is the fuel solenoid, we've got to make sure that that is the fuel solenoid connected down here on this relay. Okay, so if number 4 says fuel solenoid, then it better be the fuel solenoid when we connect to it. Or we have to make an appropriate code adjustment. Okay, so we will get to that. And I purposely made mine different so that I can show you how we adjust the code, because it's very simple at that point. All right, so we will get to that. All right, so really all we need to do is connect our AC loads, interconnect the Aquastat, and we are done with our wiring. And then we use our test code to test that. And so we're going to see how to do that today. And then we're going to look at logic, okay, which means we need to do, and I'm going to show you how to do the logic. So remember, logic doesn't have to be the code to actually turn on the relays and so on. All the logic is going to be is the code that we create the spaces in which that happens. And so we will first write logic code that purely looks at inputs, okay, and purely looks at outputs, and we are not going to worry about servo code and all the intricacies of looking at different things. We're just going to look at the logic and then just do print screens, and once we have the worlds in which we need to live and our logic is correct, then we'll add the code to actually do the fancy servo stuff for the zone valves and so on. And that way you can see how to do it step by step so that you don't have challenges in writing code. Okay? So that's what we're going to do this week and next week, so that when the 28th rolls around and that is the last day for you to turn in your projects, that's going to be the live stream. And remember, June 4 is the last day to turn in any work. That will determine your final diploma grade and so on. So we're going to get started now. I'm going to show you the boards, and then we will start looking at what we need to do based on the wiring. So let's go look at our boards. Here is a picture of the Aquastat that we did last week, and at this stage I'm just running my solid state. I'm going to start with a solid state board. You notice my test code is running, and I'm going to go point out, remember, Let me go see if I can point here with a pointer. Okay, you'll notice the little lights here. I'm just cycling through my solid state board using my microcontroller up here. In fact, yes. Remember this microcontroller here. In fact, if I slide this up just a hair so that you can see that, there we go. Remember, here was our wires that I did last week coming down to the solid state connections here, and our test code is cycling through this. Now, the reason we did test code is because we don't want to be involved with logic. We're just testing wiring. But today, the next step is to take and hook up our AC loads on this side. Right here, we're going to hook up our AC loads, and then we're going to go look and see whether they are actually working. Now, one thing that I want to be able to show you is I'm going to zoom out here. I'm going to go to another camera view on another camera. Remember how we learned that we need to separate our AC high voltage and our control loads. Okay, remember we said that we need to always keep in mind that control voltages and control signals need to be in a separate channel or separated from the high voltage lines. Okay, so let's go look at that. All right, let me see. Is this, nope, I want to show this one. Actually, let me see which one's the best one. Yeah, all right, we're going to look at this one here. Okay, and I'm going to go ahead and zoom out the board. Let me see if I can zoom it out far enough so that you can see what I want you to see here. There we go. All right. Okay, let's take a look here. Remember our transformer. Here's our transformer. And, okay, the transformer is just out of sight there for you guys, the one that I used. Let me tilt this a little bit. There we go. All right, there we go. Okay, see if I can zoom in on that a little bit. And there we go. All right. So what I've done is I've chosen, and I'll put some light on the subject there for you. Get a little bit of lighting. There we go. How's that? Okay. So I chose, now my 24 volts, here's my 24 volts, all right, and if you can see that, okay, my 24 volts coming out of my transformer, and I'm going to take it down this side of my board and over along with my low voltage wiring into where it needs to go, and we'll find out where that goes here shortly. In fact, let me go and show you. Because remember, that's going all the way over to our zone control. So I'm bringing the voltage down, or the 24 volts AC, and then we slide it all the way through here. And let me move that on up so that you can see where it goes. All right, it's going to come all the way through. All right, got to make some adjustments here for you guys so you can see where it's going. All right. Okay, now let's see if I can zoom on in there. It's going to come on through, and remember when we had this zone control, I had a 24 volt channel, and so my 24 volts is coming in all the way, and it's plugging in on this 24 volt line here, which is where my thermostat switches are that I can control it with. Okay, so there's my low voltage. So you see that stayed out of the way. Now we're going to go back and look again at where does my high voltage go. Well, that's what we got to do today. you'll notice there's my high voltage lights. Okay, I've got my test code running, and so right now it's already wired up, but I'm going to show you how I separated that AC. You'll notice that from my transformer over here, my high voltage is coming out of here. That's 120 volts running along the top of my board, and it is going all the way down, all the way across to my terminal strips where my 120 volt system is. So these lights are 120 volts, and they represent my burner, my ignition coil, my fuel solenoid, and my circulator. And you notice my test code is just cycling through. I don't care. I just want to make sure, did I do my wiring correct? So my voltage comes in, I bring it down, and you'll notice that my high voltage, let's see, where am I taking it? Well, my neutral, you see my neutral coming into here, all right, and jumps down to my neutrals for my AC loads, and then my high voltage live is actually coming along here and comes down the board, and then it's going to follow along the bottom. Now I'll get you a picture of the bottom so you can see what's going on over there. Let's see if I can get the other camera for you just a moment here. All right. Okay. All right, let's switch cameras there. All right. And then we'll position the light a little better so that you can get a view of that. All right. So you'll see this is my live coming in, and it's coming across to my solid state relays. Okay, and then from here we go out. The 4 AC lines come along, and they come out here, and then they come up, and then they branch into the terminals that are representative of the loads that you can see on the boards there. And so let me just show you that again. Let's see, that should be yeah, you can see that the lights there flashing and so on. Okay, so the key is that you get your wiring done to get your AC loads running, and we're not worried yet. We're still just running test code so that we can see what is actually going on that piece. Okay? Now, you notice the only connections we had to do was the AC connections, but there's one more. Remember, we have to connect between the zone valve control board, and which is this board here. Okay, this is our zone valve. Remember, we've got our zone motors. I got my 2 servos here, and we already know those work with our test code, and we don't have anything else there to connect. We only have the end switches. Now you remember, I used these 2 relays. That was my zone 1, zone 2 switch that is going to be calling for heat from the, they are the ones that's got to talk with the aquastat to let me know when to give me heat. Okay, so the boiler knows. And so that's where we do the or, okay, the one or the other, and they're going to go in parallel. So let's see what that looks like. Well, and because it's an interconnect between microcontrollers, I can use 5 volts. So I'm taking 5 volts, I'm bringing it down, and you'll notice that I'm going into the one center of the relay. The 5 volts is the red one. Okay, I'm bringing the 5 volts in, and then I'm jumping to the center of the second relay. And then the output of this, so either this one relay 1 or relay 2 will turn on or request heat from our boiler. Okay? And if you remember, our boiler was the single optocoupler, which is this little guy right here. And right now, if we zoom in, I want to show you something. Let's go zoom in on this. Let's take a look here. We're gonna pick this up right here. I got both the outputs of the relay. Okay, let's take a look there. Both outputs of these, all right, both of these are coming out, going up to the optocoupler, and let's see if I can zoom in real close here. There we go. That's the anode side of the optocoupler. They both connect there. So if blue or yellow brings 5 volts, this guy will come on. Now it looks like it's on all the time, but I'm going to show you that it's really not. It's just because they're switching back and forth, and then we'll look at that here in a minute, okay? And then, of course, so that's going to be the piece that we want to look at right now, is interconnecting and making sure that that is correct. So I'm going to make sure that I have the right code loaded in the zone control section, all right? Which means I need to load that. I'm going to start with connecting my Arduino, and we look at that code to load up the code where we tested the switch, the 24-volt switches, okay, to be able to see what's going on there, all right? So we're going to go look at that code, and then we'll make the appropriate downloads for that. Okay? So let me go ahead, and we're going to switch here to our screen, and let me go look at this one here, and let me get rid of something here. There we go. That goes there, and slide that over for a second. All right. Now the code, let's bring up our Arduino code. Let's take a look. Here we go. Call up Arduino. And that should pop up here in a minute. Take a look here. Okay. Any minute now. Here we go. All right. So we're going to look at the zone 1 and zone 2 end switch test. That's what we called it, okay, in our test code. And I'm going to make sure that that gets loaded into the Arduino. And so, again, let's just look what that code does. It just has the 2 end zone switches, which is the 2 relays. And all we're doing is cycling them on and off, on and off. And we want to go make sure that that actually happens. So I'm going to go ahead and turn that Arduino on, and then we'll go see what happens. Okay? Okay, let's take a look and see. All right. Just give me a second there. Okay, so let me show you a picture of what's going on there. So you can see, I'm going to show you this one here. All right. You notice that my 2 relays are switching back and forth, right? In fact, let's zoom in on that just a little bit. Now remember, they are being controlled by the, they will be controlled by the thermostats, but my test code, I don't care about that. I just want my test code to cycle those 2 relays for me, okay? So let's go ahead and look and see if that's happening. Alright, oops. Let's go back here. In fact, let's do it this way. I'm going to slide on over a little bit more. There we go. And I want to look at this LED. There we go. Now, I'm going to take this light just a little bit away so that we can kind of see the LED. There we go. Alright. So you notice the two relays switching here. Don't pay any attention to these because they're just continuing to run their test code there. What we're interested in is this optocoupler. Does it come on and off when these two are switching? Now you notice that it looks like this is on all the time. Now, if we look down here, let me see if I can, there we go, we get the whole picture in there. So you see the LED is on the optocoupler, and the two relays here are switching, but it looks like this is on all the time. Well, that's only because we're doing this, or if this or this is on. And right now when it's switching, it stays on, but it's reading this one or this one or this one or this one. But now how do we test that? Well, remember, here's my 5 volts coming in, okay, and then it's jumping over to the other relay. So let's see if this light will go out if I pull the 5 volts from the one relay. So I'm just going to loosen that up, okay, and I'm just going to slide it on out of there, and then I'll show you. Okay, we got it coming out. All right, there we go. I pulled it out. Now let's look at, there you see my LED going off. Only when this one's on, right? It's on and it's off. Now I'm going to put this jumper back in and pull it out on this side and just bring the 5 volts to this side and see what happens. Okay? Then it should only come on when this one's on. Alright? So first we're going to see it come on together again, because I'm going to slide this back in. Alright? Okay, now as we cycle, you see it just stays on, because we just don't see that switch, but it's actually on for 1 and then on for 2. So let's take 1 out, all right, which I'm just going to disconnect 1 for a second here. Okay, it's signal. Let's see if I can yank it out. All right, there we go. And now we should just see it come on when relay 2 is on. So we indeed know that our wiring is perfect, because the reason it stays on is because the other relay is taking back and forth between it. All right, so I'm going to put this in. So now we've tested our wiring, our interconnecting wiring, and we know for sure that our circuit, all our wiring is now accurate. Okay? And we know that we have test code to test that. All right? So there's our interconnect. We've made that connection to our optocoupler. We have connected our AC relays. Let's put some light back on there so we can see that. All right. We've now connected our AC relays, solid-state relays, and we've wired them up with AC coming in. And you notice how it came along the bottom of the board. I'm not mixing it with my low-voltage control voltages. My AC stays away from them, okay, and it runs all the way across and up into our high-voltage circuits, which in turn is switching our high-voltage loads, okay? My burner motor, my ignition coil, my fuel solenoid, and my circulator, all right? Now, remember I told you that originally I'd labeled these guys here, all right, in my wiring diagram. But now that I've got it wired, let's see what in the heck I did, because, you know, things changed. My loads, I couldn't get them to go to the place, or whatever reason it is, it doesn't matter, but we are now defining. I put up labels here, and I said, this is going to be my burner motor, This is going to be my ignition coil. This is going to be my fuel solenoid. And then my bottom one is going to be my circulator. Now, this is number 4. Okay? And you'll notice that number 4, when number 4 comes on, my light is on. Okay? Let me see if I can get that simultaneously here for you, just so you can see that it does happen. Let's see if we can get this positioned such that that will take place. I should be able to undo my Arduino cable. Everything should continue to run because my power supply is on. Okay, and let's go ahead and see if we can position. There we go. See if I can get enough of this in here so we can see the relays and the I'm going to actually jack this up a little bit so that I can get a more direct shot at it for you guys. And so this is going to happen now. You'll see that happening. Okay, and let's reduce the light just a little bit over here so you guys can actually see the solid state relays. Okay, so now you can see the solid state relays cycling through. Okay, 4, 3, 2, 1, 4, 3, 2, 1, 4, 3, 2, 1, and you'll notice that as those lights are blinking, the 4, 3, 2, 1 loads are cycling with those relays. So 4 is my circulator, 3 is my solenoid, 2 is ignition, and then number 1 is my burner motor. Okay? Now, having said that, you'll notice that on my wiring diagram, let's go look at the wiring diagram. Oh, what did we do on the wiring diagram? Here we go. Let's look at the wiring diagram. I'm going to slide this out of the way. My number 4 says fuel solenoid, and it's really the circulator. And so let's go look at what the Arduino code looked like. Just go take a look at that. All right, Arduino is up. Let's go see which one we're looking at. All right, there we go. Here's my aquastat relay test. And remember, I called them burner, motor, ignition coil, fuel solenoid, 8, 9, 10, and 11. Okay, now pin 8, 9, 10, and 11, where did we connect them? All right, we need to go find out. Let's go see what 8 is. All right, so now we're going to go back to our board. Originally, in my code and my wiring diagram, let me put up the board again. Okay, here we go. And now we're going to have to go look at that board and just see which one is which. Okay, now remember, I have number 4 being my circulator, 3 is my fuel solenoid, ignition coil is number 2, and burner is number 1. Now let's go look at this code. I'm going to readjust things here a little bit so we can get a good view of this, because this is critical, guys, because here's where you're fine-tuning now for what you need to do. All right, so let's go look at this, because okay, here's the guys. Okay, and let me see. So 8, let's go look at pin 8. All right, pin 8. Let's go see if I can get that a little closer for you guys so that we can take a good look at this. All right, there we go. We'll give it a moment there to focus in on that. If I can get things to stand still here for just a second. There we go. All right, got to get my tripod all set. There we go. All right, and hopefully we can get that to focus in there. Let me back this out. There we go. All right, here we go. Now we're talking. Let's go take a look real close to that here. Okay. So 8 is my green. Let's look at number 8. That's 8. Black is 9. Blue is 10. And yellow is 11. All right. Now let's go see where 8 is. 8 is the green. So if we go down to our solid state, here we go. Let's go see if we can figure this out. You'll notice that there's my green. That's pin 8, which that is really number 4. Okay? That's number 4. So 8 is the 4. So 9 is the black, which is 3. Blue is 2, and yellow is 1. Now, yellow is our number 11. Okay? So our number 1 light or load, which is our burner, okay, is really number 11 on our Arduino. Okay, if we look at this number 1 here, let's go see. That is number 11 here on the Arduino. Okay, in fact, if I can shoot this right directly over so that the numbers line up and we can see the actual writing, there we go. How's that? All right, and if I can get even a better shot, there we go. You'll see that our yellow is pin 11, blue is 10, 9, 8, and this is 4, 3, 2, and 1. All right? So, relays 4, 3, 2, and 1. So, I'm going to zoom out here just so we can see the whole picture again. Cycling through. There we go. All right. Okay. So, there we go. Okay. 8, 9, 10, 11. But 8 is our number 4. And number 4 is our circulator. So how do we deal with that in code? Very simple. We don't have to rewire anything. Okay? We're going to go in our code. And let's switch to our code, test code. And let's go take a look. Test code. Here we go. So here is, you notice that 8, which was now our number 4, is really we said the bottom there was our circulator motor. So we're going to make this number 8. Whoops. All right. 8. And then our fuel solenoid was number 3. So 8, so this would become a 9. We bring this, our 9. Our ignition coil was number 2, which is number 10. And this becomes number 11. That's all we have to do. We didn't have to change wiring. We didn't have to do anything. All we did is changed which burner motor goes to which pin, which we said that was our number 11, which was number 1, which is our number 1 load. Okay? And voila! Now all we do is recompile, and all of a sudden, that's where things are going to happen. So now when we look at when we write our code, we didn't have to change anything in the rest of the code. We only had to play that once. And now this is our test code. So now we know that our references are correct. I'm going to go ahead and compile this just so we can actually see that happen. And so that way I'm ready for that when I write my code. And this week when I'm doing my actual coding. All right, so I'm going to, there we go. We connected in there. And let's go see if I can compile this. Tools. This is port 7. Should be port 7. All right, let's go find out. port 7, there we go, and let's compile and see whether that takes it. Alright, compiling sketch. Okay. Alright, that's going there, and then I'm going to see if we can put something up here for you. Let's see if we can arrange to where I can see the okay, you guys can see the lights moving over there. Okay, so that is my cycle through from the burner, the ignition, the let's go to there's fuel solenoid, and there's my circulator. Okay, the lights. Okay, so you can see those lights coming on there. And then let's go look at the actual code. All right, because remember, our code, we now aligned with those lights. Okay, and the code will look something like, let's take a look. Let's go look. Let me slide. Well, of course, if we go look at this now, if you look at our wiring diagram, we now know that we need to rearrange our labels, because number 1 is what? What did we say? That was our burner. So I'm just going to go into my code, okay, and I'll have to rearrange those. So let me go in here. Let me bring this picture up where I can actually go change that, because this is my Word document. Let's go take a look. All right, there we go. So very simple change. I'm going to just update my documentation now. I'm going to slide this guy down. My burner is going to go up to number 1. So you can see I'm just sliding that up right there to burner as being relay number 1. And then my ignition is number 2. Okay, and that of course is 11, pin 11. Pin ignition is pin 10. Fuel solenoid is pin 9, and that's output 3. And then my circulator pump down here becomes number 4. That's the only changes I had to make. Okay, all set. And now my code and my wiring is aligned. Nothing major, because we had a plan and we are sticking to the methodologies that we have learned. Okay, and this is kind of what's going to happen in the industry. Everything is not in concrete, but you want to make it so that it makes minimal input. Did I have to change any of my wiring? No. That is why we use our microcontroller code. We can make changes and it will not affect our wiring. We don't have to touch the wiring, and all we do is send out an upgrade. All right, and so pretty cool. Okay, that's the beauty of microcontrollers. We can make changes, we can make logic changes, and we don't have to go rewire like we had to do in the old relay logic. Okay, now let's take a look. So everything there is happening like we want it to, and so I'm going to go ahead and go back to our camera right here real quick so that you can see this happening here. All right, there's our lights there, and let's go back to the other camera right here. Here we go, and you can see the little red lights flashing here. Okay, and then let's go ahead and see how that looks. All right, so I'm going to go ahead and zoom back out so that we can look at just these lights flashing. And let's see if I can pull that off for you guys here, because we've made the code update. I'm going to go ahead and pull my cable out of the way because I am running on my power. And so I've got my isolation diodes in place, and let's go ahead and take a look and see what happens here. All right, and I'll jack this back up so that I can see if we can look at the, all right, there we go. I'm going to be editing this out on the final one, so I don't have to be looking at all that nonsense. All right, I'm going to come in here so we can just see these guys. All right, and let's just go see. I'm going to bring this down just a hair. There we go. Let's lock that up. All right, and then let's take the light out of the way so that we can kind of see our red lights over there on our solid state relays. All right, so there we go. So that is 4. Okay, let's see. We're going to start 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, 1, 2, 3, 4. You notice now they're coming down. 1, 2, 3, 4. 1, 2, 3, 4. And everything aligns on our relays. 3, 4. 1, 2, 3, 4. We don't have to change any wiring. We did this in code. Everything is where we want it. This is we're going in sequence of the burner, ignition coil, fuel solenoid, circulator, and we know our wiring is good. Okay? All right. So this is where we need to be today, at the end of today, with your boards. I want you guys to make sure that all your wiring now is connected. You got your AC loads. Mr. Givens, you had an awesome board demonstration, the video that you sent me. Mr. Givens sent me a little short clip of his photo switch where he put a light on it and it would turn on an AC load to test the wiring there. That is awesome. Okay, so you know your photo switch is working. Everything should be working. And at that point, we know our board is wired. The rest of it is purely code. We can turn anything on our boards that we needed. We can look at all our inputs. We can look at all our switches with our test code. Everything is wired. Everything is cool. Now we are ready to develop our circuit or our design logic, which is what's going to happen. That's next. So what I want you guys to do, get your wiring done, make short little videos of your different test codes, and I'm going to put that up as a final. Now, your videos, because it's you can't upload that into, there seems to be a problem uploading that into the iGrade. You're going to do your wiring diagrams into iGrade with your picture snapshots of your board wiring, showing that you've wired your board. And then your little video clips, you can send those to me in Messenger or in email, but they can just be very short clips, so they're small files, so that you can do that, okay? And so that will work. The other thing is, if you want, you can post them under your Facebook page as well, okay? Either place. You just have to let me know where that is going to be so that I can see those videos for full credit. All right. Now, if there are no, I'm looking here at the comments. I'm going to type in a comment here so that I can see if you get it. Here, okay, I'm just saying, are there any questions regarding homework? All right. So getting the wiring done, that's what needs to be uploaded. Okay? Now tomorrow I'm going to be looking at, for those of you who want to work ahead, who's already got your wiring, tomorrow I'm going to be going through programming logic and where do we go from this point on? Because at this point, I don't want to write the aquastat logic in terms of getting my motors to move. I just want to build the areas in my code for those things to happen. So that's the logic we're going to be working on, okay? And then I'll be showing you that tomorrow, and then you guys can write your own logic and see how I did it. And then we'll put into place the specific pieces of code to make the actual zone motors turn and all that good stuff so that our final project is then functional. Okay? So that's where we're headed. So for today, I just want you all to get your wiring done, get your pictures done, your videos made, okay? And I see Mr. Gibbons said his good. So Mr. Versa says, so what's next? Well, what's next is you're going to go do your homework. You're going to go do your wiring. Make sure if your wiring is already done, then you don't have any homework. All right? This is just making sure that you can control everything from your board with test code and that everything is working electrically. All right? So tomorrow I will be live streaming how to approach the logic, and we'll do it in sections so that you can see how we go about to do that. All right? I'll create different Arduino files as a progression of logic development. Okay? So from there. Now, Mr. Versa, you left me a voicemail. I did get your voicemail. I responded to your resumes, and obviously that there was a breakdown in my communication there. I will get in touch with you here after this live stream, and then we can discuss what I was trying to explain to you there. All right? I've just been working on getting ready for live stream, so we'll deal with that here shortly. Okay, well, I saw that we had Mr. Gibbons here, Mr. Fogarty is here today, and Mr. Versa. I didn't see the other guys log in. I haven't heard from them yet. I did hear from Mr. Dietrich that he's working, and he'll be watching this later. In the meantime, I will have you guys make sure that I get in touch with them to let them know to watch this video in YouTube. I'll send emails out. They should also have it on their phones. Okay, so this is where we are, and if there's no other questions, I'm going to call it so all wiring is done. Yes, all wiring is done at this point because we have everything that we need. If you've got your 4 loads, which is your circulator, your fuel solenoid, your ignition, and your burner hooked up, and you can activate them through your test code, go ahead and upload those pictures and videos for me and send me the videos so that I can see that everything is cool and we are ready to start actually developing our code logic for what we need now in our circuit, okay? And I'm going to show you how to do that logic, and once you know how to do that logic, then your final exam is actually putting all the little pieces together and finalizing your circuit and your drawing. All right? Okay, so I'm going to call it a day, guys. Thank you for signing in, and don't forget, I'm going to edit this video to get rid of the no audio portion in the beginning, which I repeated once we had audio, and then it should be ready for the other guys. Okay, thank you. You guys have a good day.